Okay, so hi everyone, Senan this side, and in this video we are going to solve this number of distinct island problem on GFG, but on lead code this is a lead code hard problem. But I think so it is lead code hard. That is for premium users. I don't have premium version of lead code yet, so let's do it on GFG. Given a Boolean 2D matrix grid of size n times m, you have to find the number of distinct islands where group of connected ones horizontally or vertically forms an island. Two islands are considered to be distinct if and only if one island is not equal to another, not rotated or reflected. If you see this test case example, you have four ones placed in a square, right? Similarly, this is one island. Similarly, you have another island which has the same orientation, four ones in a square, but the output is 1. We need to keep track of duplicate islands, right? And to do that, we need to somehow keep track of the shape of the island. That is the whole point of this video. That is what it is asked from you to solve in this video. And in this case you have same in if you look at this, you have this L shaped, you have the rotated L shape, so this would be considered as different islands. But if you consider this and this, these are the same islands, so that is why the output is 3. This question is almost same to count islands. If you have done that, this should be a piece of cake for you. Just you should understand how do you actually store this shape. And to keep track of duplicates, we use a data structure known as the set. So set always has unique elements and we are going to use that. Now the basic structure would be the same thing, and you get the size of the matrix, you declare a set of vectors that stores a pair, right? That would be our set, and this is how we would be going to store our shape. We would store our shape in a vector of pair of int and int, and we will keep a visited array or matrix to keep check if we have visited a location previously or not. Just so you know, we can do this question without this visited matrix. As I have solved the last 3 or 4 problems, the idea would be the same, but just for the sake of using a visited array, we can actually use this. Now what I would do is I would go through all the elements, and if I see a 1, I would start a DFS traversal, same as we did in when counting number of islands or provinces, whatever the question was. But if you see, I have passed ing and ing 2 times, and this is something that we are going to discuss after this. So basically we are going to store my shape in the stem, and after the DFS traversal I would have my shape stored in the stem, so I would insert that into my set. Now set would contain cannot contain duplicate elements, so what would happen is it would store a single copy of each island, and in the end I would return the size of the set that would keep track of the islands. Now let's look at this. What is this? The first ing is basically the row and column from which you are calling. What is the second ing? The second ing is the base row and the base column. Now if you've used a computer before, there are two types of addresses, or addresses. So one is the absolute address and the other is the relative address. So if you have a file name, let's say abc.txt on a folder, and you are currently in that folder, so that location of the file would be abc.txt. That's the relative location of that file. But let's say if you want the absolute file, what you would go is in your C drive, then your Windows, your profile, then your Windows, the program files, and somewhere down the line you would file abc.txt. So this is the absolute import. So if I store the exact location, like the row and column of this would be considering like the absolute location, but we are not doing that. We are storing the relative location. So if there is a call from this for loop, so I would find the location or the row or column, and based off this, with respect to this node or with respect to this location, I would find the location of this one with respect to this. So I'm considering this to be the base, and relative to that I would find the location. So let's say if there whatever be the location of this one, I would say this is right of this is diagonally down and right of this one, this would be just below this one, that would be the relative location. Similarly for this if this is the base location, this is again right, this is diagonal bottom right, this is bottom. So if you see, we had the same relative location of these islands, but when you push that into the set, only one would be taken into consideration. Okay, so what I do is I take this, the base row and the base column, and let's just see what have I written. So I get the size, right? And since I've visited this element, I mark that row and column as visited, and I push back in the temp the relative location. So what is the relative location? The current row minus the base row, current column minus the base column. So we are storing the element with respect to the base element from which we are trying to call this function in this for loop. So that is how we are going to store the shape. And now I can get this up, down, left, right location and update the number of rows and columns, number of row, oh, not number of rows, but new row and new column by row plus delta row of I, column plus delta column of I. Now I check that if is this in my, so this new row and new column, is it within the matrix or not? If yes, I check is it visited or not. It should not be visited. And if it is not visited, I check if that grid new row and new column has a value of 1. So in that case, since we need to find the island, so grid new row and new column is 1, that means that could be a part of this island as well. So I call this new DFS with this new row new column, but with the same base row and the same base column. I take this temp, take this visited and the grid, and you see this temp is passed by reference. So in the end, after traversing this, I would store that into my set, and so the relative imports of this first 4 elements and this 4 elements would be the same, and therefore we would be having only a single element stored in my set. So I'll show you my notebook of how do you understand this relative import or relative storing of this shape. But let's first discuss the time and space complexity. So the time complexity and space complexity for DFS would be n square, right? And because there are 4 times n square edges, so the DFS would be of the DFS is of the order big of n square time complexity and big of n square space complexity as well, same as I have been discussing in the past 4 videos. Anyways, we would be calling this for loop. So rather than having n square, I'm saying it would be n times m because that is the size. Similarly, the time complexity for these 2 for loops would be n times n, and throughout this calling, DFS would cover n square elements in the worst case, so the total time complexity would be n times m, and again n times m for this DFS as well, but that would not be multiplied with this for loop. This DFS call would be in totality for all the for loops. So the time complexity would be n square for DFS, and for this for loop you are inserting the set, and let's say the maximum number of elements you can store in this set is the number of islands you can possibly have. So the time complexity for this 2 for loops would be n square times log of, because set takes logarithmic time, so log of number of islands plus the time complexity of DFS, that is big of n square. Again, space complexity would be big of n square, so n times m. So whenever I say n square, consider that as n times m. So the DFS would take n times m recursion stack space, and yep, this vector also takes n times m for storing the visited array, and my set would take at max the what do we say, it could basically store all the elements of this matrix, right? Although that would be in the form of pairs, a list of pairs basically. So in the worst case, it could also go to n square, but the time would be in this, while inserting, the time would be the logarithmic of number of islands. So that is the video all about. This was a difficult problem if you don't know how to store the shape and the uniqueness of shape. So that is all about this video. Let's look at my notebook to see one last time of how this relative import works. Okay, so let's look at this sample matrix. So we have the similar matrix like we had seen in the test cases, but I've made this basically smaller. So let's write down the indices of this, right? And what I do, the base I would call DFS from this location, right? So the base node would be what? 0, 0. Now subtract each element. So from this subtract 0 comma 0, this 0 comma 0, this 2, so the values would be same because we are subtracting 0 from it. But let's say if we are in this one, and this is the base row and the base column. So if you subtract this total matrix by minus 2 comma 2, what would you get? So this would be 0 comma 0, this would be 0 comma 1, this could be 1 comma 1, and this would be 1 comma 0. So this is what this is, exactly this. And since these two shapes are exactly the same, when inserting into the set you would only have a single element, and that would be this vector. So that is how this relative location is helpful. If you want, you can just see relative imports and absolute imports in Python. You would understand what I am talking about. So you've used this logic in real life before, knowingly or unknowingly, but this is the logic we are going to use in this question. That is the video. Thanks for watching, and bye.